Good evening. I'm here again to talk about removing your Xcode project from Git. First, I'll introduce myself. I'm Firas. I'm a senior iOS engineer at TrueLayer. I work on the iOS SDK for our open banking API. It's a new way of doing payments, basically. Actually, currently it's in private beta. Hopefully, we'll open source it by the end of the year. You can check my website, theinkedengineer.com. I have all my contacts, some articles I write, and all my projects, some of which is fatticazzi2.it, which is basically our way to educate people about minding their own business in a very classical Italian way. So let's start with our talk. So first, let's start with understanding what is a Xcode project. So the OS will make you think that it's a file because it actually has an extension, where in reality it's a full directory. Inside of it, for a basic setup, we find three things. So the XC user data, which is basically, by default, it contains like a plist referencing for all the schemes. And then we have the project.xc workspace, which again, it's another directory, and it holds some top-level information generated and needed by Xcode, both of which we can just delete, because even if we delete them, we navigate back and open our Xcode project, we're gonna find them back in. So 2/3 of the problem is already solved, and we're almost ready to go. Not really, because then we have the project.pbx project, which stands for a project builder Xcode project. Let's start to understand what it is. It's boring, but we have to do it. So basically, it's a old-style plist file. It's called next-style. It uses curly braces to delimit hierarchy inside of the file. It starts off with a root element. So as you can see, if you look at the root element, it looks like some weird JSON or some shit. But it's not. But if you read it, you cannot understand much of it. Like the keys don't make much sense. The values don't make much sense. The only thing like I really want to talk about is the objects. So inside of that object, we have a bunch of these things, which are like smaller objects created by Xcode. The one we see there, it's the Pbx file reference, which basically every time you put a file inside of your Xcode project, Xcode creates one of these. And basically the way it's formed is it starts with a reference ID. So basically that reference ID, it's 96 bits represented in hexadecimal, so it's 24 characters. And it's Xcode's way of referencing that file and using it around the Pbx project. Then we have the ISA, which again, from the key, I have no idea what it means, but from the value, it's basically the type of the object that we have. So in this case, the Pbx file reference. Then we have the name, which is obviously the name of the file, the path where the file lies, and then we have like, again, source tree, file encoding, last known file type. You don't know much about them, and you honestly, like, you don't care. Then we have like the Pbx group. So every time you create a folder in Xcode, if you notice, like it doesn't say new folder, but it says new group, and every time you create one of those, it creates an object like this. Again, it has its own reference ID, and then the ISA, which says it's a Pbx group. But then you have the children. As you can see, like the children, it's a reference, the one we just saw before. So it's really like not humanly readable, and we're not machines. So, and then there's like a bunch of these objects. So we have objects for configuration files, for schemes, for targets. So it's all over the place. If you hate yourself and you want to know more about this thing, there's this article by Laurent Etienne. Hopefully I'm pronouncing his name right. So basically, he did some sort of deep dive with this. Really boring stuff, but I mean, who am I to judge? So if you're one person working on one project, on one branch, you probably don't care about all of these things because you're not going to have merge conflicts. You're not merging anything. But most likely, you're working on a team, and that team is working on different branches, et cetera, et cetera. So you can find yourself in this situation. So this particular situation, I got it from Stack Overflow. It wasn't even hard to find. So this person had 140 merge conflicts, so definitely has a problem with his workflow. But regardless of that, even if we had like just 10 of these, merging it can be really hard because like you have to go through all of these references and extra stuff that you really don't need. And one thing that caught my eye was like one of the proposed solution was like take everything remote, then add back all of your stuff. which is like not a really efficient way of working. So to recap the problems with the Pbx project, it's a massive container of everything. It's thousands and thousands. Like the bigger the project, the worse it is. It has a really ugly syntax. It's super hard to read. And all of that makes it really hard to resolve merge conflicts. But unlike the other two folders, we cannot just throw it out the window because Xcode actually needs it to work. So what are the solutions? Let's start with the first one. If you're working with a package, the first obvious solution would be to use Swift Package Manager. I'm fairly sure everybody knows what it is, how it works. But just to do a quick recap, it's basically a tool for managing the distribution of Swift code. So think CocoaPods, which is probably more familiar. It's already included in the Swift toolchain, so you don't have like to download it from anywhere. If you have Swift, you have Swift Package Manager, so that's a nice thing. And then it basically uses a manifest instead of that whole Pbx project, and then it uses Xcode's internal like build systems to have a working project. So let's have a look at that manifest. So the name has to be package.swift with a capital P, otherwise it's not going to work. And basically, so we have the first line. It looks like a comment, but it's actually interpreted by the compiler, and it points out to the least needed Swift version for all of this to work. Then we have the project description, which is a module containing like the necessary pieces to be able to build your package. So we have to build a variable called package of type package. The only thing we actually need is the name, but with the name, you're not going to have nothing. You're just going to have like an empty workspace. Then we can set stuff like the platform. So in this case, let's say we only want to build a package for Mac OS. So we specify that. Then we have our product. So again, products is not really necessary, but without it, it doesn't really make sense to have a Swift package because this is basically, think of it as the public way to interact with the outside world, whoever is integrating your package. So basically, each product is something that a module that they can import. It needs a name, obviously, so they can import it, and then it needs a target, which is like the code that it actually uses. Then we have dependencies, so you can import other packages to use around your package. There you can specify the URL and the version. It can be a specific one, starting from, up until, etc. And then we have targets, which are like basically the building blocks for your package. So in this case, we have like our actual target, and then we have the test. Remember to test your code. If we have all of this and we just double click, and the nice thing is, as you can see, obviously it's Swift, so it's readable by everyone, because otherwise, what are you doing? So all you have to do, double click on it, it's going to automatically open with Xcode Project, and you're good to go. So the pros of using Swift Package Manager are that it's continuously evolving with Swift by the Swift community. So we're always getting new feature. It's always getting updated. It's super easy to resolve conflicts if you have any. Spoiler alert, you're not going to have any, but it's Swift, so it's easy to solve. Your project, it's already ready for distribution. So whenever you're done with your code, you can just push it to Git, tag it, and you can distribute your code. You can actually use it to distribute XT frameworks. This is what we're currently doing, for example, at TrueLayer. You basically set your target as a binary target and create a product pointing to that binary target, and you can just like distribute your XT framework using SwiftPM. Another thing, starting Swift 5.3, it finally got support for resources, which was a big deal breaker at first. And it's Swift 5.4, it got package dependency caching, so now every time you open your package, it has to re-download all the dependencies. And it can be manipulated from the CI, from the command line, so it's great for the CI. So did we solve all of our problems? Yes, we did, because it's not a massive container anymore, even though it's like a single file, but it's Swift, so you can actually create variables and like reference the same stuff, etc. And we don't actually like reference anything. Like we just point to a folder, and everything else we don't care about. Like Xcode takes care of that. We got rid of the ugly syntax. It's easy to read. It's not hard to resolve conflicts, and we're not going to have any anyway. And like we don't need nothing for it to work. It just works. So that's great. We're not yet ready to go because it has its own limitations. Starting with the folder structure, which is a pain in the ass because you basically have to have all of your code in a folder called sources, and each target has to have a folder name the same name as the target. Otherwise, it's stupid and it doesn't understand nothing. Then you have all of your dependencies are actually copied whenever somebody uses your package. So your test dependencies are cloned, a bunch of noise is cloned, so that's not ideal. It does not support custom scripts. So basically with Swift 5.6, it did introduce plugins which should be allowing us to support custom scripts, but it only works with like a couple, like Swift format, XcodeGen, but a lot of scripts, they still don't work. So actually the feedback was way underwhelming, but hopefully it's going to get better with Swift 5.7. And it's not, because of this, it's not suitable for iOS apps, so we cannot actually build an iOS app using Swift's package manager. And a limitation is actually that's being evolved with Swift, because since it's being evolved with Swift, we have to wait for like new Swift versions to get new features, to get bug fixes. It's not like you can just open a PR and you have it fixed. So maybe we can, like most of these limitations we can probably live with. The only problem would be the iOS apps, because most of us are actually are actually working with apps, not SDKs. So what about iOS apps? So actually we have two solutions. Actually we have many, but like I chose two, which is like I think are the best, but still. First one is we're going to go over. It's called XcodeGen. So basically what XcodeGen is, it's a command line tool that generates your Xcode project on demand. So what that means is you can just get rid of the Xcode project altogether, put it in your git ignore, you don't need it, and whenever you download the source code, you run one command, which we'll see later, and it automatically generates a Xcode project for you. It's open source, and it's mainly maintained by Jonas Kolb. That's his Twitter handle. And it's super easy to install. All you have to do is run brew install XcodeGen. And basically, it uses a manifest and your folder structure, so it's kind of similar to Swift Package Manager to generate your project. That manifest is basically, it's called project.yaml, and it's customizable. It doesn't have to be that name. You can pass it as a parameter in the command, and you can customize it. It uses YAML. If you're not familiar with it, think if JSON and Python had a baby and it came really bad, that's YAML, basically. So let's have a look at that, a simple project.yaml. So basically, we start off with the name, so it's the name of the project we're gonna create. And again, this is the only thing you need to actually have it running, but obviously you cannot do nothing with it. So the bare minimum I thought we could need to have like something to work with would be obviously a target. So basically targets is listing a set of targets that we have. We create one called my application. Inside of it, we have to specify the sources. So basically there we pass an array of folders that we have our source code in. It doesn't have to be called sources or resources. You can literally call it anything you want. The reason why I called it like that, we'll see it later. We set the type, so if it's an application, framework, or whatever. We set the platform to iOS. And then we just run, we go to our root directory, we run XcodeGen, and it automatically creates this Xcode project. As we can see, it has basically everything to start working. It has a target, it has a deployment information, it has a name, the sources. So as you can see, in sources, we already created an application folder, a views folder. So like everything is just imported automatically. But I don't think anyone here supports 15.4. We always like supports at least 1 or 2 versions earlier. Apparently Telepass 11.0. So let's say we want to modify that. So what we can do basically is just jump back into our editor. We can add a deployment target. So we set it to 13.0. And we add some settings. So we set our targeted device family to 1, which again, it's not ideal because from the value you don't understand much, but 1 would be iPhone. 2 would be iPad, and 3 Mac. Then we have we set our custom product bundle identifier. We jump back into our root directory. We run XcodeGen, and again, we can see the changes reflected. So now our deployment target is set only to iPhone and support iOS 13. Our custom bundle identifier is set. and we're good to go. So let's look at something slightly more complicated. So now let's say we have our main app that supports iPhone, iOS 13, but then we have our networking module, because you should modularize your app. And it supports iOS 12, because we built it before, we never updated it. And it supports iPhone and iPad because we have two separate apps, one for iPhone and one for iPad. And then we have the networking module, uses Alamo Fire because we're lazy and we don't want to do our own networking. And then the main app uses the networking module. So how can we go about that? So what we basically do is we take our old file, we start by adding on top the packages, which is the list of Swift packages that we want to include in our project. It supports Cartage as well. Doesn't support Cocoa Pod, but what you can do is like run pod install after you generate your Xcode project and you're good to go. And then in our targets, basically we create a new target for networking. We assign it sources. We set a custom deployment target, which is 12, it's not 13. We set our target, we add 2, which is the iPad. We set our dependency to type package and we point to Alamo Fire. And then in our main target, we set a dependency of type target and we point to our networking. We jump back into our root folder, run XcodeGen. And again, we see automatically, we open our Xcode project and we have the new sources folder networking that it's included in the list of sources. We have the new target with all the custom stuff we added. Actually cheated with this because there's a bug in XcodeGen now. If you have the M1 Mac, it adds Catalyst as a target as well. You have to manually remove it. Hopefully it gets fixed. So yeah, but I mean, you can get this. So yeah, there's a lot of stuff that we can do with XcodeGen. Literally anything that you can do with Xcode, you can, like inside of Xcode, you can do with XcodeGen, but we don't have like the time of the word. So let's just go over some pros. So basically it's actively maintained. That's a big pro. Last update was probably a week ago. It's well documented. I'd give it a solid 8 out of 10 because you have everything. The problem is everything is in a unique markdown file, so it's really hard to like get what you need. It's just like crammed all together, but you'll find it sooner or later. It supports multiple manifests, so we don't have to have like a huge manifest with like thousands of lines. You can split it in different ones and then just like import it and use the stuff from separate manifests. It does support custom build settings, scripts. So let's say you wanna, after every time you build your code, you wanna run SwiftLint, you can add that as a custom script on your target, and it does that. So you can do it for every target, specific targets, whatever you want. You can add resources from outside of Xcode. By that I mean, like technically when you're working with Xcode alone, well, every time you cannot just drag and drop something in your sources folder from the outside. You have to like import it back from inside of Xcode, which is painful. With this, basically you can just drag and drop, run XcodeGen, and you have your stuff up and running immediately. It's humanly readable. I mean, YAML, it's still nay, but I mean, it's readable. And you have a unique source of truth. So basically you have one place where if you have any doubts of what target we're supporting, what's the name of this, what's the name of that, like you have one source of truth for all of your stuff that you can actually read. And again, it runs on CI, so you can basically push your code, you can remove Xcode from your Xcode project from your repo and build the project on your CI to run your tests, run your UI tests and everything. So that's a big plus. But still, it has a few cons. So basically, the syntax is still not ideal. For me, it's awful, but let's call it bad. It doesn't support variables, so like you have to repeat stuff. It supports environment variables, but it doesn't support like local variables. So you have to repeat stuff over and over and over again every time. And it's really error prone because like if you can make typos, like let's say you call your target something and you have to like include it in other places. Since you don't have variables, like you have to write it every single time. And you can make typos. I mean, nothing huge, but like not ideal. And there's no community basically. So even though it's maintained and everything, there's no like somewhere where you can like chat with people, understand like what to do about it, like how to do certain stuff, etc. Jonas is like he's available on Twitter, but I mean like he has his own life as well. And it's basically some sort of like a one-man show. So you can open obviously your pull request and contribute, and he'll be more than happy to review it. But it's like only like he's the lead maintainer, so it's not like you have a bunch of people that can just like jump in and do stuff fast. So it's not bad, but it's not ideal. So did we solve our problems? So we had all our previous problems plus the lack of support for iOS. As we can see, we did, except for the ugly syntax, which again, we can live with and go home, but I'll keep you here for a few more minutes because I want to talk to you about twist. So I'm not sure if it's twist or twist because everybody pronounces it differently, but let's call it twist because it's easier to pronounce. Basically what twist is, again, it's a command line tool that helps you generate your Xcode project on demand. It's open source and it's fully written in Swift, super easy to install. You just run this. And again, it's driven by a manifest that you can add everything you need into and you're good to go. So let's start by talking about the manifest. So it's a single project.swift file. Again, in this case, it's not customizable in itself. It has to be project.swift, but you don't have to have everything inside of that. So basically, Twist has this concept of helpers, where you can generate, so basically you have to create a folder called Twist in your root directory, or actually everywhere because it just like looks in the whole folder hierarchy. So you have to create a folder called Twist. Inside of it, you can put any file, any folder, anything you want. It's not opinionated. So what Twist does is basically it compiles that folder and it creates it as a framework called project description helpers, and it exposes it to your project.swift file. And that way you can actually import stuff and you have all the benefits of Twist. So you can even have like some public variables, some internal variables. It's super nice. Everything is in Swift. So you feel right at home. And if you're familiar with Swift Project Manager, you'll feel right at home as well because it's fairly similar as far as like syntax and stuff. So how do we create it? Actually, it's super easy to create it. You just navigate to your root directory, create a project.swift. But rather than just like opening the file, actually, obviously you can open it and just like write a bunch of stuff. But you can run twist edit. What twist edit does, it creates a temporary workspace called manifests, inside of which, which we'll have later, our helpers will have them right here. So here, basically, you can just create a twist folder, add all of your stuff, and you can use it because basically it compiles it, creates it as a framework, and it's a workspace. You have that framework inside of your workspace. You can import stuff and do whatever you want. And since it's a workspace, you can actually compile your code just to make sure that everything is correct and nothing is broken. So let's start by creating a simple project. Again, even in this case, all you need is a name. And to create it, you run twist generate, and it automatically creates your Xcode project for you. Currently, for whatever reason, I'm not 100% sure why, it creates a workspace as well, not only an Xcode project, even if you don't have like any need for the workspace. I heard that there's a issue to solve that thing. If anybody has time and want to solve it, please go ahead. So let's have a look at a more detailed manifest. So let's take the same old scenario that we had. So we have so we start by creating a target. Again, since it's Swift, we can create it as a variable. So we set a name, platform, product, and as you can see, like the platform and product, they're enums because since it's Swift, Twist can leverage enums, so we don't have to type everything. And you can create obviously your own, etc. Then basically we set our deployment target and all of that. The only thing we need to do is create a project, like a variable called project of type project. We give it a name, which would be the name of the workspace being created. And then we assign the array of targets that we want to include in that project. So if we jump to our root directory, run twist generate, it's gonna create our Xcode project with everything. So basically, everything is nice. So the reason why I didn't add the resources at first, because Twist has this concept called resources accessor, and it does a few stuff. So if we add a resources property to our target and assign the resources folder, what Twist does is two things. So first, it creates a unified access to resources. So basically, when we have resources on our application, we use bundle.main. If it's inside of our framework, we usually create a class, then point to that class and fetch the resource folder, resource URL. What Twist does is basically replaces these two with bundle.module. You're not obligated to use it, so you can. It's like, let's say you adopt it now, you don't have to like change your code around, but it's recommended to use it. The other thing it does, it actually leverages XcodeGen. We just talked about it. And it creates all these synthesized resources for you. So your strings, colors, images, even your plist file, like everything, you can just access it with the dot notation in Swift. So it's super, super nice. So yeah. Now let's take the previous scenario and we want to add the networking dependency. Here it becomes a little bit more complicated. So recently Twist released Twist 3 and introduced a whole new concept of dependencies. So what Twist does is basically it has its own, let's call it first-class solution for dependencies. So what it does, it downloads your dependencies. Again, it supports Swift Package Manager and Carthage. And technically, there is a project to do the same thing for Cocoa Pods. But since like it's losing popularity, they're not sure if it's going to be done or not. Hopefully it will be. But for now, like you have to do the same thing and run Cocoa Pods separately. But basically, you have Swift Package Manager and Carthage, and what it does basically, it downloads these dependencies, it transforms them into a Twist primitives, which are their own frameworks, and they can be either static or dynamic. And then it includes these dependencies as frameworks inside of your project. So it creates a workspace with other frameworks as targets. And there's a bunch of benefits from this. Most of it is regarding caching. So basically, this allows them to cache these dependencies, even a precompiled version of these dependencies. There's a whole documentation around it that we'll get later to it. But I mean, it's really fantastic. Like the actually, I should have been here. It would have been easier. Never mind. So as I said, like it creates like precompiled version. It makes caching easier, and you just use it like any other framework around your app. And actually, it resolves another problem, which we talked about previously with Swift Package Manager, is basically when you add your package to your project using Swift Package Manager, it adds all of this noise. So you have the tests, you have a bunch of README, like a lot of noise that you really don't need. Whereas what Twist does, since it creates, like it just takes the sources and it creates its own framework. So you basically only have source and derived, which inside of derived, you basically have your plist. So all of that noise, you don't have it anymore and you don't need it. So that's super fantastic. I actually figured it out like half an hour ago. So awesome. So basically, how do we add dependencies? So it's a multi-step. So basically, first we, let's say we're in our root folder and we don't have already our twist file, the famous one I just talked about. So we start by creating a twist file. We navigate to it. And we create a dependencies.swift, which is an own manifest for the dependencies. And we run twist edit again, which opens our workspace. Inside of the workspace, we edit our manifest and we add a variable of type dependency. Inside of it, we specify the type of the package we want to support. And we can, again, like we set the URL and the requirements. And the platforms we support. Currently, it doesn't support multi-platforms, but they're working on it. So you have like one package, one platform. Then we have to close the workspace. We run twist fetch. And what twist fetch does is everything I explained before. So basically, inside of the twist directory, it creates another directory called dependencies and adds a bunch of stuff. So basically, we have the graph of all our dependencies, the resolve to keep track of the versions. They actually make a copy of the directory, so in case you need the whole README stuff, you can find it over there. And the package.swift to like, because basically it treats the whole thing as a single package for itself. So to do this whole thing to our network, so basically what we do, obviously we already added the Alamofier in our dependencies. So we jump back in our main manifest and we create a new target called networking. We add all the bunch of stuff that we need and we just add a new variable called dependencies that points to an external and we specify the name. Obviously, for example, here it was just like a quick example. So I used like the string Alamofier. Obviously, if you have a bunch of them, you can just create an enum with like a raw value and just like use it that way, which makes it easier since it's Swift. And then in our app target, we just add the target and specify the name. Again, since it's Swift, we can just like access the property inside of the inside of our target property. So to avoid like having to type stuff, so that's super nice. And then we run twist generate, which generates our project, and we have everything we need. So we have both of the targets. We have the twist dependencies. So all our Swift package manager dependencies will be in one folder, Carthage in the other. And we have literally everything we need to work. So to do a quick recap, obviously, again, just like XcodeGen, anything you can do in Xcode, you can add it here. So build settings, scripts, anything you want, you can do it there. So the pros of using Twist. First of all, that's for me like was a big plus. It has a great community on Slack. Just visit their website. It's twist.io, and you can get all the links there, over there. On Slack, you have any problem, you can reach out. Like the whole community will answer you, will help you. If you have a problem, they'll even help you like open your full first pull request. I had a personal issue, like the bug I told you about on XcodeGen, which basically when you generate the iPad and iPhone version, it includes the catalyst as well. That what's not like the default one we wanted. I explained myself on the channel, and that was like my first contribution to the project. And it was like, it took 2 days. So like that's a big plus for this project. It's super well documented, super well documented. It can handle literally anything you throw at it. And since we have like the whole helper stuff, so it's not like everything in one folder, you can do stuff as you want. Like you can have constants, you can have everything you want. We have the resources accessors that we talked about. Everything is in Swift, so yay. And it runs on CI as we saw with Bitrise, so it's super easy to integrate on your CI. So finally, we managed to solve all of our problems. And actually, Twist is way more than this. So it has, I just like listed 4, but it has like 10 at least, extreme useful features that it offers. So the possibility to cache your targets and dependencies like locally and remotely. So if you cache it remotely and like one person builds the project, like the whole, like unless you modify the stuff, the whole team doesn't have to build it anymore or compile it. It gives you like, let's say you have a complex project and you want to have a graph of all your dependencies. It does that with a Twist graph. You have Twist test, which is super nice that you can throw at any version that you want, any device, and it will run like custom tests for like schemes, everything. Like it's fully customizable through the command line, so it works great with CI. And as we saw with Bitrise, it supports like automatic caching. So obviously, like one of the biggest problems is whenever you push your code, the CI runs, somebody reviews your code, you have to modify something, and then you push like one space, and then you have to rerun the whole test. So with like caching, you literally don't have to do nothing, and it's super useful. And then there's like something called Twist Scaffold, which basically it's a way to bootstrap components. So you just like write templates for like certain components. You run it, and it automatically creates like the folder structure and everything. It's super nice. There's what else? There's a bunch of functionalities. Like everything is on their website. It's super nice. Obviously, it's not all rainbows. There's a couple of cons. So these are like the main stuff to be aware of now. So Twist test has a small problem currently. It hangs on the CI because there's a bug in XCBeautify, which is another Twist library. You can basically just like comment it out and it solved the problem. They're working on solving it. So hopefully this will be solved soon. No native support for CocoaPods yet, so you don't have the advantage of the whole caching system and everything for CocoaPods. And some dependencies are having issues, like I think it's like problem between like Swift Package Manager and Twist, but again, it's really rare, like it depends on what you're using and it's case by case. And whenever like the problem arises, because they had one with like Crashlytics, but apparently this morning it was working, I don't know how. So the current ones are Realm and RX Swift. So Shai won't be happy, but sorry. So yeah, that's it. Before we start Q&A, I'm gonna answer 3 questions that probably gonna be asked. Most probably it's what happens if one of these, like we use one of these tools and they're not supported anymore, they get deprecated. So it's really simple. You just go to your git ignore file, you remove the Xcode project, and you just comment it back, and you're good to go. Because it doesn't, the way XcodeGen and Twist are built, they don't actually interact with your code, so nothing is gonna break. The only thing to be aware of in Twist, since now they have their first-class support of dependencies, the only thing that you will have probably to do is like just go to Xcode, add the packages using Swift Package Manager normally, and you're good to go. But like it's like half an hour work. It's nothing, so it's super safe to use them. Can they coexist with Swift Package Manager? Absolutely. That's why, for example, in my examples, I use sources and resources as folder names, because that way you have, if you work on a package and you can use like XcodeGen or Twist to get all the plus stuff that you get from an actual working environment, but still you have your stuff ready to be published. And what I do personally use, so I used XcodeGen for 3 years. It was super nice, except for the YAML part. It did everything again, but for the last 3 months, I migrated to a new company and a new system. So now we're using Twist, because of not only because of how you generate code using Swift itself, but because of all the extra stuff that you get from caching and testing and everything. So it's super nice, and I highly recommend it. And that's it. If you have any